Okay, let's get right to work here. It's 5:21. This is video number 97. We're talking about perfect square trinomials, however, with two variables. Let me get that all the way over there so you can see that, okay? And we're kind of familiar with this because we've seen it in the previous lectures. We saw, and I'll focus your attention here on the right-hand side over here, that when we define these things, we were saying a squared plus b squared plus 2ab, and we're following the same rules here, so you get used to these things. So I'll move over here a little bit, and we see that 2a plus 3b squared, when I use the FOIL method, is here, let me go over here and again slow down. 2a squared is 2a squared is 4a squared. 3b is 3b squared when I squared both of those guys. And then 3 times 2 times 2, the ab tags along, and there you go. You should understand what I'm doing. Shouldn't be a big mystery to you. So normally if you're in class, I'd say, okay, so someone help me fill in what's going on here. And hopefully half of you are yelling out, of course, this is just the minus to do that. And here again, we talked about conjugates. They work when there are two variables here. The conjugate of 3b, negative 3, they're conjugates of each other. And I'm going to do a little bit of this to check your understanding in a couple of minutes. Okay, so that's all quickly done. We've exposed the idea here that you can have two variables. There might be restrictions on these variables. We don't know what they are. If they represent a square, we might want to talk about that. So now let's go right on to a cube. And we're not really going towards cubes, at least at this point here. But it has to be pointed out that the volume of this cube, and I just want to make sure that everybody's good on this, is x plus 1 cubed. So it's some number that you choose. There are probably restrictions. You don't want the side to be negative, and you go on. But there are the numbers you choose. Plus 1 would be the edge of this cube, and you'd, of course, cube the sides and get the volume. And I'll quickly do out the math, because what I'll do is I'll turn it into a binomial times a trinomial. I'll let you see what I come up with, and I'll leave it there for the time being. So x plus 1 squared times x plus 1 is just the equivalent of this, right? So if I go to the left over here, so that means I get x squared plus 2x plus 1 times x plus 1. And I just did all that in my head. I explained it to you. I might have put the 1 here and the 2x here, but in my head I flipped it over into standard form. And now that means x squared times x. And now I'm just going 1 by 1, x squared times 1. You see? And now I go to the 2x, which we've done a number of times before. And there's a 2x. I'm making sure that you're getting to see everything. And then where are we? The last one, there's a plus x, and there's a plus 1. A little crammed, but the thinking is very on target. So these combine, and when I put them together, I get this configuration, which is going to make sense, especially down the road. And this represents the volume of that cube, any number plus 1, and it's a polynomial, it's cubic. It's got 4 terms. Every term is different. You should take a close look at that. That also becomes something that we want to talk about. Notice how I took advantage that x plus 1 squared is the same, times x plus 1 is the same as this. We're just getting comfortable with this new math. So with that done, I'll get to what I really wanted to do and work a little backwards. Okay, I'll give you assignments on this, and we'll slow the pace down now so you can catch up. Done a lot of work this morning, and like I said, too far, too fast doesn't help anybody, especially the weaker students. You do have videos that you can play back and get help. Okay, and I will include more assignments and probably won't get to factoring until next week, so you have a chance to work out these problems. So let's see what's going on here. I have this problem, and I'm going to write out this polynomial and introduce this idea, follow up with what we just did. And we can see it's got two variables, which I'm trying to teach you to accept, okay? And it's a quadratic trinomial, okay? And A is any number we choose, B is any number we choose. And so the question is this a perfect square trinomial with two variables? It either is or it isn't. So I'd like to work backwards and show you that it is. And hopefully this is going to make sense for you, because we'll follow these ideas up and with a multiple choice question like this in the near future. So I go to the first term, 4a squared, and that's clearly a perfect square. So let's just put it over here. When I take the square root of 4, I get 2, and the square root of a squared is a. So there we go, I took the square root of that. It's a perfect square. 1b squared, okay, so that's just b. The square root of b squared is b. You can work it backwards anytime you want, okay? So let's multiply this. We'll write it out like this, hoping that it works. And then we see that 2 times 1, because the coefficient is 1 here, times 2. Ah, so it makes me think right away, since the second guy is negative, that makes this negative. This times this is this. This times this is this. And this times this and this times this is this. And I found it. So what does it represent? It represents a square. With restrictions, of course. The square is 2a minus b. You want me to put it over here so you can see it? That's what it represents. This represents the area of a square. This is a perfect square trinomial. You should be following what I'm saying. And this is the area of this trinomial. So you went from the area to the side, which could easily turn into the perimeter. So P would equal 8a minus 4b, because I'm multiplying one side by 4b. And you're learning to think this way in math as your numbers get more complicated. So here you have this perfect square trinomial with two variables. You found one side. You know you can represent this by a square, since it's a perfect square trinomial. And there you have a perimeter. So you went from the area to the perimeter to the sides. And that's what you do in math at your age, okay? And now I'm going to do another one. I'll do it over here. And this one will not be a candidate for what we're doing. And I'll write that out over here. And hopefully it makes sense. This is 9a squared, and this is plus 4b squared. And we're minusing 2ab. And the question is, can I represent this as a square like I did on the last problem? We got it clear over here. Is this a square? Can I represent it cleanly with integer answers? Because that might be something people might quibble about that down the road. And can I write this out and turn it into a square? So let's take our criteria one more time. The square root of 9a squared is 3a. So I'm sort of jumping the gun here. I'm kind of hoping I can write this out. This won't work, by the way. We'll give you an exercise that allows you to do that. And then certainly 4b squared, and there's a minus here because obviously, like before, I put the plus and we really wanted the minus there. And this perfect square of 4b squared is 2b. So that's good. And now 6 times 2 is what? 12 times 2 is what? And what do you see here? So this doesn't fit our criteria. The middle term, or in this case the last term, doesn't fit with what we're doing over here. So when we write this out, we're not getting the correct answer. So what is the correct answer? Well, we can write it out right away without any problem. The first two terms are perfect, but 2 times 3 times 2, and there it is, right away. Okay? So you'd be expected to do that. Factoring means going from here to here, and you'll certainly be doing that. Also, just a real quick little note, I've been going over 10 minutes now. I can use any variables I want, x, y, c and d, m and n. I'll try to remember to do that. And let me just, in case I didn't do everything right, we got the math that we did here before we start talking about assignment number 37. So there you see, 2 variables, how we can work that, and I'll definitely put that into our assignment.